I'm back. Found a calculator. So here we go. So we've got 29 is equal to 80 times e to the negative 4k. So what we should do next, again, we're trying to isolate the variable. We want to try to get k by itself. Well, I have this 80 out here out in front. So in order to undo multiplying by 80, I should divide by 80. And divide both sides by 80. And so 29 divided by 80, guys, when you do these calculations, I like actually 4 decimal places. Well, it's nice, this one is actually 4 decimal places. It's 0.3625, 29 divided by 80. And so that's going to equal e to the negative 4k. All right. So now, we haven't really done anything in terms of logarithms or exponents yet. We've done some really just algebra, moving things across the equal sign. So let's keep going. So the next thing I want to do is I want to try to move the variable down. It'd be nice if I could move this exponent down so I could work with it. Well, the question you need to ask yourself is, how do we do that? Well, we're not allowed to do it yet. What do we have to do first to both sides of the equation? And hopefully you came up with, I have to use a logarithm. Okay, I have to do a logarithm. So I have to take, you can do ln of both sides, you can take log base 10 of both sides. Some of your calculator can do easily. I always like to do ln, especially when you have e in there. Probably a good idea to use ln. So let's do ln of 0.3625, and that's going to equal ln of e to the negative 4k. All right, looks like you can still see that. Okay. So let's keep going. I'm going to move this up here. All right, so let's get it. Keep it moving here. So I've got ln of 0.3625. Let me write that down again. Is equal to. Now what I can do is I can take this negative 4k. Since we have a logarithm out in front, we can use the power rule and just move that down to the coefficient. Rewrite as a coefficient. So it's negative 4k times ln of e. Well, I don't know if you guys remember this, but ln of e is one of your properties that we've talked about. If you think about it, what it means is, what power do I need to take e to? Remember, ln, it means base e. So what power do I need to take e to get e as the answer? Well, the answer is to the first power. So when you evaluate ln of e, and you can type this in your calculator if you wanted to, ln of e is always 1, okay? So you're going to be left with negative 4k is equal to ln of 0.3625. And then what I need to do is solve for k. So I need to divide by negative 4. So let me go ahead and type that in. So it's ln of 0.3625 divided by negative 4. Enter. And I got positive 0.2537. If you round it to 4 decimal places. Guys, I want you to go at least 4 decimal places because I want you to be as accurate as possible. And 4 I think is good enough. So 0.2537 is equal to k. All right, so I'm going to pause right there. That was only to find k. All right, we really haven't found much. We found the constant. So that will help us figure out the big picture equation. So I needed to find k first before I could find my time, how long it takes. I think we were after how long it takes to get to 20 degrees Celsius. Yes. Okay, when will the egg be 20 degrees Celsius? So let me flip it back over. And if you have this framework already, the next equation, you're going to solve it pretty much the same way. So you got to keep an eye on this and when we do the big picture equation. All right, so here goes. So remember, we had the big picture equation. We said earlier that our temperature, we wanted to be 20. Everything else is pretty much the same. The temperature, the medium, and the initial temperature didn't change. But the only thing I can do now is I can plug in what k is and just try to solve for t now. So let's do it. By the way, let me simplify first. Hopefully I have enough room here. This would be 20 is equal to 16 plus, this would be 80, e to the negative, well, instead of negative k, I'm going to write as negative, what was that number? It was 0.2537. And we still have t, so it's negative negative 0.2537 t. Okay, all right, sounds good to me. Now let's keep it going. So like I said, you already have a framework as to how to solve this equation. The first thing we did last time was we subtracted this number right here. So I'm going to subtract 16 from both sides. So 20 minus 16 is 4. 4 is going to equal 80 times e to the negative 0.2537 t. Okay, then I have to get rid of this 80, so I'm going to divide by 80. So 4 divided by 80 is what? I should know this off the top of my head, but it's 0.05. Can you guys see this? Yes, you can see it. And that's equal to e to the negative 0.2537 t. Okay, so now again, it would be nice if I could move that exponent down. Well, before I do that, I have to take a logarithm of both sides. So I have to take ln of both sides. So let me go ahead and do this. I'll do it up here. Hopefully I have enough room. So it's going to be ln of 0.05 is equal to, I guess I'll show all my work here because it's the first one. It's going to be equal to ln of e to the negative 0.2537 t. So now that we have a logarithm over here, what we can do is we can take this exponent and move it down. Right, rewrite as a coefficient. So it's going to be negative 0.2537 t. And then it's times ln of e. I guess you could write that if you wanted to, but if you remember, what is ln of e? Well, the answer is 1, okay? So I really don't need to write it, but you could say times ln of e if you wanted to. That's just 1. ln of 0.05 on the left side. And then how do I solve for t? Well, in order to get t by itself, I've got to divide by whatever it's being multiplied by. So I'm going to divide by that negative 0.2537. Okay. And so you just have to type that into the calculator now. So when you type this in, let me do that real quick. So it's going to be ln of 0.05 divided by negative 0.2537. Okay, and I got 11.8. And that would be in minutes. The reason I know it's in minutes is because if you read the original problem, it says 4 minutes later. So since it said 4 minutes later instead of 4 hours later, you know your answer is going to be in minutes as well. So about 11.8 minutes is how long it's going to take for it to cool down to 20 degrees Celsius. So maybe that's the temperature you like to eat it at, 20 degrees Celsius. Now, by the time you do this problem, it'd probably already be cooled already. But anyways, yeah, that is the idea. That's how you determine how long something's been cooling using Newton's law of cooling. So now I know it sounds like a lot. There's a lot of stuff that went into it. This is something you're going to be expected to do on a test. So just get used to it, guys. We're going to get some more practice. I've got another video coming that has another example here. I'm going to give you guys some examples to try on your own, but pretty much all Newton's law of cooling problems are similar to that. If you have any questions, just let me know, but hoping this makes some sense, and we'll keep it going with the next video. All right, that's all I've got for this video. I'll stop right there. Actually, these 2 videos, but yeah, let me pause it and catch you later.